All right, so we're going to continue, and this time we're going to add and subtract polynomials. Adding and subtracting. Pretty much, it's only combining like terms. So when you add or subtract like terms, the exponents do not change. When you add or subtract like terms, the exponents do not change. And to be a like term, it has to be the same variable with the same exponent. That makes them like terms. So what I like to do is I like to write my two polynomials stacked on top of each other. And when I write them, this one is in the correct order because it goes the highest exponent down. But notice how this one, the x squared, is in the middle. So when we stack them on top of each other, be careful because you want to stack like terms. And so I'm going to rewrite 3x squared plus 11x plus 4. Now, if I was missing a term, I would just leave a space for that. Like if I didn't have an 11x, if it was just 3x squared plus 4, I'd leave a space so that when I stack them, I have a place for the plain x. So like down here, this negative 5x needs to go under this one because those are like terms. And then the x squared goes here. That's really 1x squared. And then this minus 13. And that helps you see the like terms. And this is an addition problem. So we're adding. What's 3 plus 1? 4. So this is 4x squared. Your exponents don't change. What's 11 plus negative 5? So we have plus 6x. And then 4 plus negative 13? Negative 9.
So you just drop whatever x is there. What about
Yep.
if they got like a common?
Then, like, let's say I was missing this minus 5x. I would just bring down the 11x. And it would just be plus 11x there. I would just, like, if this one also had an x cubed on it, I would just have the x cubed. I wouldn't have anything to add to it. But it's still there. Yeah. All right, number 18. What's different about number 18? It's subtraction. So what I prefer to do is I don't like subtraction problems because when you go down to stack them, sometimes you forget that it's subtraction. So it's really easy to change it to addition problem. What you do is you change the minus to a plus, and then after that you change every sign. So this positive 2x squared becomes negative 2x squared. This plus 2x becomes negative 2x. This plus 17 becomes minus 17. And then it's an addition problem just like number 17. So we have 5x cubed.
Why don't you change the 1?
Because basically what I'm doing is taking this minus 1 and distributing it. You don't distribute backwards. You only distribute after. So 5x cubed minus 2x squared plus... Now, what would normally come after an x squared? An x. But I don't have a plain x, so I'm going to leave a space because in this next one, there is a plain x. I need to leave a space for that. So I'm going to leave a space and put this plus 4 at the end. This one was missing a plain x, so I left a space for that. So when I stack, this negative 2x squared goes here because those are both x squareds. This minus 2x would go here, and then the minus 17. If you didn't leave this space, you would probably put this negative 2x squared under there, and this negative 2x under that one, and you wouldn't have like terms on top of each other. You want all of your like terms right on top, like this. So these x cubes, I don't have anything to add to that, so I just bring down the 5x cubed. What's negative 2 plus negative 2? What? Negative 4x squared. Negative 2 plus negative 2. Now here, I didn't have anything to add to the negative 2x, so I'm just going to bring down minus 2x. And then what's 4 plus negative 17? Negative 13. Questions? All right, number 19. Is it addition or subtraction? Subtraction. So we need to make it an addition. So this becomes a negative 2x to the fourth and a minus 3x squared. All right, so I have 2x to the fifth. I'm going to leave a space because for x to the fourth, right?
Yeah.
Now, x cubed would be next. I go 5, 4, 3. Do I have an x cubed in either one of these? No. So you don't necessarily have to leave a space because there's not anything there. If you leave 2 spaces, that's not a problem. But I don't have anything to put, so I would have a minus 3x squared plus 1x minus 7. And then in my other one, I have a negative 2x to the fourth. It's going to go here. And then a minus 3x squared. Whoops, sorry. So bring down my 2x to the fifth. I have a minus 2x to the fourth. How many x squareds do I have? Well, I have 2 things of them, but negative 6x squared plus x minus 7.
If we can do it without the switching the sides up top, is that okay?
Mm-hmm.
Because I feel like when you do it, that's just going to mess me up.
All right, number 20, is it addition or subtraction? Subtraction. So let's make it addition. This becomes a minus, minus, minus. If they were negative, then I would make them a positive. But for some reason, all of these examples were just that way. So we have 2x to the fourth plus, that's 1x cubed. I need to leave a space for x squared. I don't have any in my first, but I do in my second. A plain x, I don't have any plain x's anywhere, so you don't have to leave a space for that. And then a minus 6. And then a negative 3x to the fourth minus the 2x squared. gets over here. And then a minus 5. What's 2 plus negative 3? Negative 1. X to the 4th. Bring down your 1x cubed. Bring down your minus 2x squared. And then negative 6 and negative 5 is what? Negative 11. Any questions on adding or subtracting? Now, what I show you is stacking. That's not necessary, but most of the time it helps to visualize if you see your like terms on top of each other, and it keeps you from missing something. And it also helps you to put them in the correct order doing that. Okay. Now, multiplying is a little bit different. So you probably learned FOIL method with multiplying. Do you all remember FOIL? First, outside, inside, last. And FOIL really, it works really for when you have two binomials, so 2 and 2, 2 terms and 2 terms. But if you get more terms than that, FOIL, it's really easy to miss something. So remember when we did the box method with factoring? I'm going to show you basically the reverse box method. So we start with the outsides and fill in the insides. And that way it's a good organization tool to help you not miss anything. So I'm going to make a 2 by 2 box because I have 2 terms and 2 terms. So really, I mean, if you think about this, when we did factoring, this looks like the factors. So we're basically going in reverse. I'm giving you the factors and you're going the opposite way. On the outside, on one of them, I'm going to put x and a minus 7, and the other x and 6. One on the left, one on the top. It doesn't matter which one you put where. And so then in each square, you're going to multiply what's at the top and what's to the left. So this one, I'm doing x times x. What is x times x? X to the second. In this box, I'm doing 6 times x, 6x. In this one, I'm doing negative 7 times x. And then this one, I'm doing 6 times negative 7, negative 42, multiplying. You added. And then many times, not every time, but a lot of times, your like terms will kind of be diagonal from each other, and they'll be really easy to spot, your like terms. So we have x squared. When I combine my like terms, that means I'm adding. So 6x plus negative 7x is what? Negative 1. You did negative 6 and negative 7. And then minus 42. This is essentially FOIL method, but instead of just writing them all out, you've got them in a box. And that way, as long as you fill in every box, you know you didn't forget something.
And do it the same way for 22?
Yeah. So now 22, a lot of people see this, and they want to do 2x squared and 3 squared. But that's really not what you do, because 2x plus 3, when I square that, what that means is I have 2x plus 3 times 2x plus 3. It doesn't matter how many times I tell you this, there will always be people that don't do this, and they just do 2x squared and 3 squared. In my Advanced Algebra 2 class, I reminded them of this before they took their test, and I still had people do that. So I'm going to tell you and tell you and tell you. But when you have 2x plus 3 squared, it's the same thing as having it written side by side. And so we do use the box method here. So we have 2x plus 3, 2x plus 3 in your box. So this first box, 2x times 2x is what? 4x squared. What's 3 times 2x? 6x. And then 2x times 3 is, and what's 3 times 3? 9.
That'd be 4x squared plus 12x plus 9.
Yep. So here's my like terms.
So you add a lot of time.
Yep. 4x squared plus 12x plus 9. So if you want to write that on there, that you add like terms. Now remember, it's super easy to check your answer. Pick some random number to store as x and type in your question and then type in your answer and see if they match. It makes it super quick to check. All right, number 23. This time, my box is going to be 2 by 3. Because I have 2 terms and then 3 terms. So my box is going to look like this. It'll be a little bit longer. Now, if you make your box long ways going up and down, that's fine. You'll just have, your box will just basically be rotated. So we have an x plus 4, 2x squared minus 6x plus 9. What is 2x squared times x? 2x cubed, 2x to the third. What is negative 6x times x? Negative 6x squared. And 9 times x? Good. Two x squared times 4. 2 times 4. 8x squared. You did 4 squared. 4 to the second power. Yep. 2 times 4 is 8, and then you have the x squared. Negative 6x times 4. And 9 times 4? 36. And you'll notice your like terms are here diagonal. So we've got 2x cubed. How many x squareds do I have? 2. Because 8 plus negative 6 is 2. What's 9 plus negative 24? Negative 15x, and then plus 36.
Why did you add negative 6 and negative 8?
That's a positive 8. So negative 6 plus 8 is 2. I did add them. Yes. When I multiply x squared times another x, when you multiply, you add your exponents. So this is really an x to the first power. So x squared times x, you would add your exponents to get 3. 2 plus 1 is 3. All right, what size box am I going to have on number 24? a 3 by 3. Yep. So it doesn't really get harder. There's just more of the same stuff, really. Just takes longer. It doesn't really matter which one you put on the top and the bottom. 3x squared, or the top and the side, minus 4x1, 2x squared, 5x negative 9. So if I multiply 2x squared times 3x squared, what do I get? 6x to the 4th. Because when you multiply variables, you add the exponents. So 2 plus 2 is 4. 5x times 3x squared is 15x to the 3rd. Then we have negative 9 times 3x squared. X squared. See if you can fill out these next two rows. All right, so the second row, you should have negative 8x cubed, negative 20x squared, 36x, and then when you're multiplying by 1, it's just 2x squared, 5x, and negative 9. And your like terms are still diagonal. So we get 6x to the 4th plus 7x cubed minus 45x squared plus 31x minus 9.